Welcome to our journey through the vastness of space. Today, we will explore the intriguing possibility of using resources from the Oort Cloud, specifically icy objects containing water and other volatiles, as raw materials for interstellar travel. This concept bridges the gap between the familiar confines of our solar system and the uncharted territories beyond. Can we harness these distant resources to fuel humanity's next giant leap? How might these celestial waypoints transform our approach to exploring the stars? Interstellar travel has long been a dream for humanity, but the vast distances and harsh conditions of space present formidable challenges. The nearest star, Proxima Centauri, is 4.2 light-years away, a journey that, even with the fastest spacecraft we currently envision, would take decades or even centuries. According to Dr. Sarah Seeger, an astrophysicist at Massachusetts Institute of Technology, the main barriers to interstellar travel are the enormous distances and the need for sustainable resources during the voyage. Overcoming these challenges requires innovative solutions and extensive preparation. This is where the Oort Cloud comes into play. The Oort Cloud is a spherical shell of icy objects surrounding our solar system, extending from about 2,000 to 100,000 astronomical units from the Sun. It's a reservoir of comets and other small bodies, containing vast amounts of water ice and other volatile substances like methane, ammonia, and carbon dioxide. Dr. Harold F. Levison, a planetary scientist, notes, the Oort Cloud holds a significant amount of primordial material from the early solar system, which could be invaluable for future space missions. This material has remained relatively untouched for billions of years, offering a pristine source of resources. But how can we tap into these resources? And what could this mean for our future in space? The concept of using Oort Cloud resources for interstellar travel revolves around the idea of establishing waypoints or refueling stations in the outer reaches of the solar system. This would involve capturing and processing icy bodies to extract water and other necessary compounds. These distant outposts could become the gas stations of the cosmos, providing essential resources for long-duration missions. Water is not only vital for human survival, but also a key component for producing rocket fuel through electrolysis, which splits water into hydrogen and oxygen. This could enable spacecraft to refuel on their way to distant stars, significantly reducing the amount of fuel they need to carry from Earth. Imagine a future where our interstellar vessels stop by icy comets to top off their tanks. This vision could become a reality with advancements in space technology. Dr. John C. Mather, a Nobel laureate in physics, explains by leveraging in situ resources, we can drastically reduce the logistical challenges and costs associated with long-duration space missions. How soon can we develop the technology to make this a reality? Developing the necessary infrastructure will involve significant engineering challenges. For instance, spacecraft will need advanced robotics to capture and process icy bodies efficiently. Additionally, we must develop storage solutions for the extracted water and other volatiles to ensure they remain usable throughout the journey. For interstellar travel, advanced propulsion systems are essential. Nuclear fusion engines, matter, antimatter drives, and even more speculative concepts like black hole drives have been proposed. These systems require significant amounts of fuel, which could potentially be sourced from the Oort Cloud. Dr. Robert H. Frisbee, a propulsion system designer, states future spacecraft will need to carry large amounts of propellant. The ability to refuel in the Oort Cloud could make these missions feasible. However, the development of these propulsion systems and the infrastructure needed to support them will be a monumental task. There are practical challenges to consider. Navigating to and capturing objects in the Oort Cloud would require precise calculations and advanced robotics. The distances involved mean that any mission will need to be meticulously planned and executed to ensure success. Moreover, the infrastructure needed to process and store the extracted materials must be developed. This includes creating processing facilities that can operate in the harsh conditions of space and designing storage systems that can keep the extracted resources stable over long durations. However, these challenges are not insurmountable. With international collaboration and sustained investment in space technology, the vision of using Oort Cloud resources for interstellar travel could become a reality. Are we ready to take the necessary steps to make this happen? While we've never managed to identify an object within the Oort Cloud directly, no less than 5 man-made spacecraft will eventually visit it. These are the remains of interstellar probes from previous missions: Voyager 1 and Voyager 2, Pioneer 10 and Pioneer 11, and finally, New Horizons. These pioneering missions, though not initially intended for Oort Cloud exploration, will provide invaluable data as they pass through this distant region. The data collected by these probes will help us understand the composition and behavior of Oort Cloud objects, informing future missions that may aim to harness these resources directly. Harnessing resources from the Oort Cloud also raises economic and ethical questions. Who will have the right to mine these celestial bodies? And how will the benefits be shared among humanity? What measures will be in place to protect the pristine nature of these distant objects? These questions must be addressed to ensure that our exploration efforts are both sustainable and equitable. Balancing the drive for exploration with the responsibility of stewardship will be crucial. International treaties and agreements will likely play a significant role in governing the use of these resources, ensuring that all of humanity can benefit from our ventures into deep space. In conclusion, the icy objects of the Oort Cloud present a tantalizing opportunity for supporting interstellar travel. By utilizing these distant resources, we can overcome some of the most significant barriers to reaching the stars. As we stand on the brink of a new era in space exploration, the potential of the Oort Cloud serves as a beacon of hope and innovation, guiding us towards the next frontier. Will we rise to the challenge and unlock the secrets of the Oort Cloud? The answer lies in our willingness to push the boundaries of what is possible. Thank you for joining us on this exploration of the Oort Cloud and its potential for interstellar travel. Don't forget to subscribe for more fascinating insights into the universe and beyond. Safe travels and keep looking up.